So today we're doing this physics lab 7 at home. As you can see, I got the mass of the black hole in kilograms, so my data is right. And so our main problem is trying to find the mass of that black hole. To do so, I took the code that we wrote in lab. I changed a couple of things. I changed the mass of the star, obviously, and then down here in this line, this is where I calculate the mass of the black hole, the net force times the radius squared divided by the mass of the star divided by the gravitational constant. I subtracted the location vector of the black hole from the position vector of the star to get that radius, instead of just having that be 0 like we did in lab. So those are the things I changed, and when I ran that, I got this thing. You can see here the net force and the perpendicular force are very similar to each other, and don't be fooled, this parallel force is actually 10 times as big on this as it is in quote-unquote real life. So this should actually be 10 times smaller. You really wouldn't be able to see this at all because I changed the scales there so it would be visible. But you can see that the net force here and the perpendicular force there are very, very close to being the same length. They're just in slightly different directions. But yeah, those are very similar. And then doing that, I got the total mass of the black hole to be 2.38 times 10 to the 31st kilograms. And that's right, according to the website. So then, we used obviously the momentum principle to calculate those. Updating with the momentum principle here, and the net force equals the change of momentum, so that's important. And then we also use parallel and perpendicular forces and changes of momentum parallel and perpendicularly, and so we use that to get the star to curve around the black hole and to find out the net force on that. So that's good. So as you can see, the little green arrow here says that I'm right. So there's that. The data we used is just what I downloaded, and then I used the same parameters we used in lab. Again, the things I changed I told you, and the arrow scale here I changed that so you can see that a little better. And gravitational constant, Earth years, and then so I have the I don't know if I mentioned that earlier, but when I ran this, I put this in here. That's actually the black hole. That's where the position of the black hole will be. Given that it actually, you can see it, but you can't because it's a black hole. You can't see those. As you can see, it has those little arrows there. That's net force. That's perpendicular. That's parallel. And mass of the star. I mean, it's all in here. Using the parallel and perpendicular changes of momentum and magnitude to do all those things. What else? The model fits the data well. It has to, because they gave us the data, and the model just kind of follows the data. So I don't really know why that's on here. It wasn't really an experiment, but it was successful. And yeah, that's fun. So I just try to keep it short for you guys so you don't have to watch it for that long. And have a good day / weekend / probably you'll be getting this on a Sunday night, so have a great Sunday night.